Force and Newton's second law. When we talk about force, we're dealing with any push or pull that's acting on an object. When the force on an object is increased and the mass stays the same, the acceleration increases. When the mass increases and the force is constant, the acceleration decreases. So we can put that information into an equation which is referred to as Newton's second law equation. Our net force equals our mass times our acceleration. So F net equals m times a. So to put a key, our F net is our net force. We know the units for net force are newtons. M stands for the mass of the object, which is in kilograms. And A stands for acceleration, which is in meters per second squared. So when we look at this particular equation, force is on the opposite side of the equation from mass. That means that they're directly related. If we were to increase the mass, that would increase the net force applied, as long as the acceleration is held constant. Net force and acceleration are also on opposite sides of the equation, so they're directly related. So if the net force is increased, the acceleration will increase. And when we look at mass and acceleration, they're on the same side of the equation. That means they're indirectly related. So if the net force is a constant and the mass goes up, the acceleration would go down. And vice versa, if the mass were to go down, the acceleration would go up. Now, when we talk about weight, we're dealing with the effect of this acceleration due to gravity. We know that acceleration due to gravity is always in the downward position. And weight is dependent on the location because gravity varies depending on where an object is. Mass is the amount of matter in an object, and it's constant for a particular object. In other words, it doesn't depend on where you are because it's independent of gravity. This leads us to a variation on our net force equals our mass times our acceleration. Now we're just going to change our force to the force due to gravity. So we're going to say Fg equals g times m. So our Fg will be the force due to gravity, which is in newtons. And if we're talking about the force due to gravity on Earth, we're dealing with the object's weight. The mass is in kilograms. And g is the acceleration due to gravity in meters per second squared. So if we talk about the weight of an object on the Earth, our acceleration due to gravity would be 9.8 meters per second squared. So that's what we would substitute in for g. Equilibrium. When the acceleration on an object is 0, the net force is 0 as well. And there are two types of equilibrium. There's static equilibrium. That's when the object is not moving. And there's a dynamic equilibrium, and that's when the object is moving at a constant velocity.